me how to do this?
I don't even know how to solve that. Gosh, the exam is fast approaching.
Yes, but I still don't understand the lessons.
Oh, Nicole! Are you having a hard time in your mathematics?
Yeah.
Yes, and our exam is fast approaching. We don't have any understanding yet.
So you better watch math video on YouTube.
Math video?
Well,
Yes.
can you send us the link?
Yeah, I will send it tomorrow.
Oh, thank you. That's a big
Thank
help.
you.
Thank you.
Thank you. Bye.
Hello everyone, welcome to Everyday Math, where math is an everyday routine. Anyways, I'm Professor Matt, and for this video, we are going to talk about modeling with algebraic and transcendental functions. So let's get started. So first, let us compare an algebraic function and a transcendental function. An algebraic function is a function that can be defined as the root of a polynomial function. And a transcendental function is an analytic function that does not satisfy a polynomial equation, in contrast to an algebraic function. Mathematical modeling is a process of using various mathematical structures like graphs and equations to represent real-life situations or real-life problems. What a math model is, it's just a representation for a problem in order for us to understand the problem more and in order for us to find solutions to a problem. So let's start with modeling with algebraic functions. This is our problem 1. So what I did is I made a table for the given, which is the time and the pages left to read. As you can see, the given is at 4 hours, the reader only has 330 pages left. So we have that information right here. And we also have the given pages per hour, which is 55 pages per hour. So we can look for how many pages the book is, which is question number 1. How long is the book? By just adding 55 pages to 330, because we are trying to know how long is the book at t is equals to 0. That means the reader hasn't read anything yet. So let's just input that in the calculator. Wait. So 330 plus 55 is 385 385 plus 55 is 440, and 440 plus 55 is equal to 495, and 495 plus 55 is equal to 550. So as you can see, we have the rate of change. Time is equal to plus 1. Plus 1 because the time interval we have is, as you can see, it increases by 1 hour. And the rate of change for the So now that we know the initial pages of the book, which is 550, we can figure out how long did the reader spend to read the whole book. So we can just divide 550 divided by 55, and the answer will be 10 hours. And as you can see, if we also divide 550 by 10, the answer will be 55, which is consistent with 55 pages per hour. And so our function will be L of t is equal to negative 55 t plus 550. So all this is saying is that we can approach this problem in many ways, and we can find solutions for this problem in various ways, and this is like the representation. This is the algebraic function. This is an algebraic function that can represent this problem. And as you can see, we have the answers here. Initial pages is 550 pages, and how many hours it took is 10 hours. And we can get that from by using this equation. And that's it for example 1. So let's proceed to another problem. This is problem 2 for modeling with algebraic functions. So we have a cylinder. Let's just let x. Let's let the radius. Let's let r equal to x, and let's let the height equal to 5x. The volume of a cylinder is given by volume is given by V is equal to pi r squared times h, where r is equal to x and h is equal to 5x and v is equal to 355 centimeters cubed. So we can just plug it in. Let's plug the corresponding values in this formula. So the given volume is 355. Go to pi, and r is equal to x, so let's just put x here. Then times the height, which is 5x, times 5x. Then, I'm sorry, there's supposed to be a power of 2 here, so let's proceed. So let's just solve this. This can be written as 55 is equal to 5 pi, and since we have another x multiplied to the pi x squared, it will be 5 pi x to the power of 3. Next is, let's try to separate the x. So let's divide 5 pi to both sides, and it's going to be x to the power of 3 equal to 355 to the power divided by 5 pi. Then what we're gonna do is we're just gonna get the cube root of this. So the cube root is 4.754 centimeters, and that's gonna be our radius. So that's it for problem number 2. Yun na yun. Let's proceed to another problem. This is the third problem for modeling with algebraic functions. So the physics teacher moved 4 meters east, 2 meters south, 4 meters west, and then 2 meters north. So we have our given here. D is equals to 12 meters. Then T, which is time, is equal to 24 seconds. And we are looking for S, which is speed. So let's solve for speed. Speed is equal to D over D. So let's just go ahead and plug in that. Then speed will be 0.5 meters per second. And the next thing that we are looking for in this problem is the average velocity. So for velocity, we're gonna need delta x and the time. We already know time, which is 24 seconds. Delta x is 0 because the final and initial positions are the same. See, 4 meters, 4 meters, 2 meters, 2 meters. So there's no change. So let's go ahead and solve for velocity. Then the velocity is 0 meters per second. And this is consistent because there's no change in position, therefore there's no velocity. And so that's it for our example number 3.
Hi, welcome to Everyday Math, because math is a daily routine. So since Professor Matt is not around, so I will be your professor for today, and I am Professor Ria. So for our problem 1, it was said that the pole tilts toward the sun with 8 degrees, and the shadow has 22 feet, and from the tip of the shadow to the top of the pole has an angle of 43 degrees. Now the question is, what is the height of the pole? So let's say that this angle is A, this angle is B, and this angle is C. So let's say that this angle is A, and this angle is B, and this angle is C. Now the question is, what is the height of the pole? So let's say that the pole is A, and the hypotenuse is B, and the 22 feet is C. Now, to get the height of the pole, we need first to get the values of angle B and C. So we all know that A is 43 degrees, and B is equal to, since it is 90 degrees, so 90 degrees plus the 8 degrees is equal to 98 degrees. Now the angle B is 98 degrees. And for the C, we all know that the total angle of triangle has a 180 degrees. We just have to subtract this with angle A and angle B. So minus angle A minus angle B is equal to 180 degrees minus 43 degrees minus 98 degrees is equal to 39 degrees. And our angle C is 39 degrees. Now, to finally get the height of the pole is, we need to use sine law. Sine law. So, the height of the pole is A, let's set A, over its opposite is angle A, so sine A is equal to, the shadow of the pole is C, over its opposite is angle C, so sine C is equal to, let's cross multiply it, it will give us A is equal to C all over sine C times sine A. Substitute the values. A is equal to, the C is 22 feet, and the sine C is 39 degrees, and times sine A, angle A is 43 degrees, and A is equal to 23.84 feet. And this is the height of the pole. So for our next problems, we have transcendental functions involving integrals. For the second problem, it was said that Nicolo has a circular lot with a radius of 5 kilometers. 5 kilometers. And he wanted to have a space, circular space with a radius of 2 in the center. 2 kilometers. So the question is, what is the area that is not within 2 kilometers? So we're going to find this area, which is that is not within the 2 kilometers radius. So the area of a circle geometrically is pi r squared. And to support this, we're going to use integral. So the area integral of 0 bounds to 2 pi, and the radius is integral of 0 bounds to r dr theta. And we're going to integrate this with respect to r. So it will give us 2 pi r squared. Copy the exponent and bring it down. Copy the exponent of 2, bring it down, and integrate or evaluate it to 0 to r. So since it is divisible by 2, cancel 2, and will leave us pi r squared. So going back to the problem, so pi r squared. So since we're going to find the area that starts from 2 and end up in 5, so we have to subtract it with another pi r squared. So let's substitute the values. Pi, the radius of 5 squared, minus pi, radius of 2 squared, is equal to 5 squared of 2 is 25 pi, minus 2 square root of 2 give us 4 pi. 25 pi minus 4 pi is equal to 21 pi. So this will be our easy way to find the area. So next, or to prove this, or the other way, or the moderate way to find the area, is we're going to use integral. So the integral of 0 to pi, and for the radius integral of 2, since we're starting from 2 and end up in 5, 2 bounds to 5 r dr d theta. And again, we're going to integrate this with respect to r, so it will give us 2 pi r squared over 2 evaluated to 2 to 5, or bounds to 5. So copy 2 pi. Since we have 2 radius, we're going to do the same thing here. So r squared minus r squared over 2 evaluated to 2 to 5. So substitute the values. 2 pi 25 because 5 squared is 25 and the 2 squared is 4, all over 2, cancel 2 will give us pi 20, or since it's 21, so the answer is 21 pi. So they have the same value. This. So for our third problem, it was said that if I have a cylindrical cup which has a height of 5 meters, so cylindrical cup, say like this, cylinder, which has a height of 5, so that as z from here, starts here is 0 and has a height of 5m and has a radius of 4 meters. So the question is, what is the volume? So we all know that the integral of 0 for the area, 0 bounds to 2 pi, and the radius is the integral of 0 since it started from the center and then up to 4. So 0 bounds to 4, r dr d theta. So since it involves volume, we're going to add an integral for height, the integral of from 0 to 5. So 0 bounds to 5 dz to volume. Now, we're going to integrate this with respect to r, and it will give us 2 pi, the integral of 0 bounds to 5, and integral of 0, 2 pi, 0 to 4, or to simply get this is 2 pi r squared over 2. Then the integral for the height, 0 to 5 dz. So cancel this out, cancel, and will give us pi integral of 0 bounds to 5 r squared dz. So substitute the value of r, which is our radius, 4. So pi, the integral of 0 bounds to 5, 4 squared dz. So pi integral of 0, 5, 16 raised to the power of 2, 4 raised to the power of 2 is 16, so give us 16 dz. Now, r dz or z is 5, so we're just going to 5, 16 times 5 is equal to, will give us 16 times 5 is equal to 80. Copy the pi, and the unit is m³. To support this, we all know that the formula to get the volume of the cylinder is V is equal to pi r squared times the height. So V, copy the pi, the radius of 4 squared times the height is 5 is equal to pi. 4 squared is 16 times 5 will give us 16 times 5 is equal to 80 pi, and the unit is m³. So we got the same answer.